This example, we are going to solve the following optimization problem. So we want to find out what is the biggest cylinder inside a sphere. So in order to solve that, we need to find out what does it mean by the biggest cylinder. We mean the volume of that cylinder. So in order to calculate that volume, we can easily draw a figure like this. So this h is actually half of the total height of that cylinder, okay? And the volume of that half is equal to h multiplied by the area of this circle. So the area of that circle is pi r square, and multiplied by h will give you the volume of this side of the black cylinder, and you multiply by 2 gives you the whole volume of the cylinder. So the objective function will be equal to OF is equal to 2 pi r square multiplied by h, and the decision variables are r and h. So there are some constraints in this example. So if you look at this graph, you can easily see that the r small r square plus h r square is equal to r capital square. So r capital is the radius of the big sphere, and r small is the radius of the base of that cylinder. So we do have that constraint, and also we know that the small r is between 0 and r capital. So you see here, and h is as well the same. H is between 0 and big R. So in order to solve that, we need to use the Pyomo package. So here you see from Pyomo environment, we import everything, and also we may be using the NumPy. And these are the comments which is not going to be used. So we define a concrete model. It can also define as an abstract model. No worries about it. So r is the parameter. We initialize it with number 1, and also h and r are both variables, and they are ranging between 0 and model.r. So instead of defining a new constraint, I just put the boundary of the variable inside the variable definition, and we can initialize it with some numbers between 0 and r, and I use the r here. So, and also we do need a constraint. For example, model.c is the constraint that is describing the problem for me. Expression is equal to model r square plus model h square is equal to model.r capital square. So as you already noticed, Pyomo distinguishes between the r capital and small r. Yeah, and also the objective function is the following expression here. I'll write it down. So it will be 2 pi r square multiplied by h, and the sense of the optimization is maximize. And since the overall model is a nonlinear programming, I can use the IPOpt solver, and the result is given here. So let's run each tab separately. I run the first tab and then the second tab, and you see the number increases after running that. And then I use this tab. So after passing this tab, the optimization is solved and everything is stored here in my model, and we can print the output. So the r value is 0.82, h is equal to 0.58, and the objective function is 2.42, and I have used 2 points for rounding purpose. And also if you don't want to use the round function, you can easily print the whole number here. Okay, so you can easily update any numbers that you see in this example and adapt it to your own values. Thank you very much.